In this video, we will be using operations with rational expressions to be able to multiply and divide them. The first example has to do with monomial rational expressions. First thing I'd like to do is rearrange the numerator and denominator by grouping the coefficients together and the variables together. So let's do that now. So I'm going to rearrange the numerator. I'm going to group the coefficients, the numbers. I'm going to group the variables together by like kind or by same base. And then denominator, I will do the same thing. This will allow us to be able to reduce the fractions a little bit more easily, in my opinion. So what I'm first going to do is take a look at the coefficients and reduce them by a common factor. You can also use the prime factorization of these numbers and break it down and then reduce it that way as well, but I prefer finding a common factor. So here there's a common factor in my numerator and denominator of 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. With the remaining coefficients, I will look to see if I can reduce by a common factor again in the numerator and denominator. Here, 12 and 24 share a common factor, or 24 and 3, so you have a choice. I'm going to use 12 and 24. 12 divided by 12 is 1, and 24 divided by 12 is 2. So 12 is the common factor here. If you look at your remaining numbers for the coefficients, there is no other factor that divides evenly into the numerator or denominator. So we have 2/3. Now we're going to reduce each variable. Here, again, we're using our rules for exponents as previously learned. Here we're going to subtract our exponents. X to the 4th minus 2 is x squared. X to the 1st power minus 3 is x to the negative 2. Being that this is multiplication, it has a negative exponent, and we did learn that if you have a negative exponent, we can make it positive by placing it in the denominator. But since we have to simplify this fraction, it's okay to leave it in the numerator, and then we'll just use our rules later for adding with the same base, adding exponents with the same base, that is. So either way, either place it in the denominator using x squared, and it would look like that, and then you will reduce it, or you can keep it in the numerator and then work with it from there. I will leave it in the numerator. Now we're going to take the y's, so y squared divided by y cubed. Again, we're going to subtract the exponents. So it's y to the 2nd power minus 3, which is y to the negative 1. Again, we can use that rule, or we can leave it in our numerator and then we can simplify from there. Since there isn't any y here to combine with the y 5th in the denominator, we will leave y to the 5th power in the denominator. Once again, if we look at our numerator and our denominator, the job is to now consolidate. So we're going to consolidate these x's since they are the same base, and here we're going to add exponents. So I will add my exponents using that rule. So we have 2/3, and then x to the 0 power, but again we'll have to rename x to the 0 power, because again we remember that x to the 0 is always 1. Here we'll use our subtraction rule for dividing using the same base. So y to the negative 1 minus 5 is y to the negative 6. And again, we will rename. Now that we've consolidated our numerator and denominator, now we can do the renaming process. So here, my final answer will be 2/3. X to the 0 is 1, and y to the negative 6 can be renamed as a positive exponent as y to the 6th power in the denominator. My second example is multiplication involving binomials and trinomials. So here are our factoring techniques. So here we will need to factor. Factor all numerators and factor denominators. I have a combination of techniques here. I have a GCF here to factor. I have another GCF method here. X squared minus 4 is the difference of two perfect squares, so that is an AC method of factoring, and then the trinomial is an AC method as well. So here we're going to factor out a 3, because 3 is shared by both 3 and 9, and I'm left with x minus 3. In my denominator, I'm going to use my AC method, so again, you might want to go ahead and do this out on your paper. Oops, there's no squared there, my apologies. So it's x plus 2 and x minus 2. And then that's going to be multiplied by, again, if we take a GCF out of that, they share an x in common, and I'm left with x minus 2. And if you factor your denominator using techniques you've learned for factoring, you should be all set. Okay? Now, again, just like example 1 above, I prefer to write this as one big fraction. So I'm going to kind of connect these here so that now we have everything being multiplied in the numerator and everything being multiplied in the denominator. So now I can look to see if they share common factors, just like before. So here I have x minus 3. Do I find an x minus 3? Yes, I do. That's a common factor, so we're going to reduce or divide by that x minus 3. Here I have an x minus 2. Can I find an x minus 2 in the denominator as a common factor? And I do. Again, I can reduce that. I don't have any numbers or coefficients to reduce. I do not have a single variable as a factor to reduce. So now with my remaining numerator and denominator, I will now consolidate or multiply it together. So I have 3x in my numerator, and the denominator has x plus 2 and x plus 1. That would be your final ratio. The last and final example has to do with division. Well, it's really no different than any of the other examples we've just did, especially example 2. It's very similar. We're going to multiply by the reciprocal. Based on our definition for dividing fractions. So we're going to have x squared plus 2x minus 8 divided by x squared plus 4x plus 3, and now I'm going to multiply and flip my second fraction, the reciprocal. Now we're going to look at this as if we're doing example 2 above. So factor numerator and denominator, write as one numerator and denominator, and then reduce. So we're going to factor AC, GCF, just to highlight what you will be using, or factoring techniques you learned prior. So I factored my numerator, the x squared plus 2x minus 8. I will factor my denominator, x plus 3 times x plus 1. The numerator of my second fraction, or my second rational expression, is a GCF method. And then x minus 2. I'd like to put that in parentheses so I know it's a factor. Again, I'm just going to kind of connect these together and show it as one fraction. Okay, we're going to reduce by seeing what they have in common for a common factor in the numerator to denominator. Here I see an x minus 2 being shared with an x minus 2, x plus 1 shared with an x plus 1, and for factors there's no other single coefficient, so I cannot divide this 3 with that 3 because these are not factors. This is an add-in. So here I should have 3 times x plus 4 divided by x plus 3. Final answer.